This is what happens when you burn a mixture of zinc and sulfur. It makes something called zinc sulfide, which can be used to make glow-in-the-dark powder. Making it this way is fun, but the quality is usually garbage, and this stuff won't glow. To make stuff that actually works, it's a much more difficult process, and a little while ago, I was able to make some. I did this for a video on my YouTube channel, and I also used it to make a weird, creepy baby thing. This is luminol. It's a chemical that exhibits something called chemiluminescence, and when it reacts, it can release light. To make this happen, I just have to add water to a beaker and a decent amount of sodium carbonate. Then I can add the luminol, which can dissolve in this solution. I also need to add some sodium bicarbonate, and this solution is basically ready. Now, I just need to make an iron solution by mixing together 3% hydrogen peroxide and something called potassium ferrocyanide. To make the luminol glow, I just have to mix these two solutions together. So today, I've decided to dissolve some cotton, and to do this, I need to make something called Schweizer's reagent. It's pretty simple to do, and I start by adding concentrated ammonia. Then into this, I can add some copper hydroxide, which starts to dissolve, and it makes a really nice dark blue solution. Now I need some cotton, and I'm just going to use a cotton ball. This solution is able to dissolve cotton, but it's kind of slow, and it's not like adding sugar to water. This is now a few minutes later, and to get rid of the rest, I just have to keep stirring it. Okay, so it looks like everything has disappeared, but the cotton hasn't been destroyed or anything. I'm gonna try to get it back, and to do this, I just have to pour it into some dilute acid. It unfortunately came back as a bunch of pieces, and now I just need to filter it off. So today, I'm gonna be making some fireballs. To do this, I have to start with some white powder called calcium acetate. Now I have to add some water and dissolve it. This should normally make a colorless solution, but this is all brown because I made the calcium acetate myself, and it's not very pure. Not all of it dissolves, but that's fine, and now I have to pour it into isopropyl alcohol, which turns it into a gel. Now I can squeeze out some of the extra alcohol and make some flammable jelly balls. This is something called crud cutter that I got from a hardware store, and it's apparently used to clean up things like spilled paint or oil. But what I think is cool about it is that it's nearly pure sodium polyacrylate. This is the same stuff that's used in baby diapers, and it's able to absorb a huge amount of water. It looks like only half of it was used, but it was apparently still able to absorb everything. What I'm left with is a dry powder, but it's actually mostly water. A while ago, I bought these small little tube things from China, and they all contain a small amount of tritium. Tritium is chemically almost the same as hydrogen, except it has 2 extra neutrons. This makes it about 3 times heavier than normal hydrogen gas, and it's also radioactive. So what people do is trap it in small tubes like this that have a phosphor painted on the inside. When the phosphor is hit by radiation, it emits light, and the color depends on the phosphor that's used. They can glow like this for as long as 10 to 15 years, but some of the radiation does get out, and I can detect it with a Geiger counter. This is a bunch of nasty aluminum trichloride, which is commonly used in chemical synthesis. It's nasty because it's anhydrous, meaning it's completely dry, and also really reactive. It even reacts with moisture in the air, and it lets off acidic HCl gas. However, all this stuff is really impure, and I have no use for it. So, I'm going to destroy it by just dumping it into some water. This is concentrated nitric acid, which is an acid that's commonly used in the lab. In general, when most acids get on your skin, they don't do much as long as you wash them off really quickly. But nitric acid is different, and I'm gonna sacrifice my finger to show you. It reacts with proteins in skin, and it causes them to change color. To make sure that it doesn't cause any real damage, I have to quickly rinse my finger in water for about 10 minutes. After that, I can add some sodium bicarbonate, which makes the color a lot stronger. The damage here is only to the outer dead skin layer, and it's probably going to be like this for the next few weeks. This is a bunch of magnesium metal. It's one of the lightest metals, and it's commonly used in a lot of things like cars and electronics. But what I think is really interesting about it is what happens when it's lit on fire. It burns with a blinding white light that singes your eyeballs. Once it's on fire, magnesium is notoriously hard to put out, and it can explode if you put water on it. It can also burn under sand and in CO2. This is nitric acid, and it's one of the few acids that can react with copper. But oddly enough, it doesn't work well when the acid's pure. This is because of something called passivation, where a layer of oxidized copper forms and it covers the surface and protects the rest of the copper. To get it going, I have to add some water, which will dissolve the protective layer and let the acid attack it. This more dilute acid can completely shred the copper, and all the metal should eventually disappear. This is sodium cyanide, and it's quite useful in chemistry, but it's probably best known as a poison. When it's pure, it's perfectly white, but this stuff is slightly yellow, and I think it's because it's old. Now, when it comes to poisons like sodium cyanide, they are very toxic, and it can make them a bit scary to work with. However, what I find surprising is that it still takes a decent amount for it to be dangerous. In this vial, I measured out the amount that it would probably take to kill me. It's not a lot, but it's definitely a lot more than I'd ever eat accidentally. The biggest danger is getting it on my hands and having it go through my skin, but I can just avoid this by wearing gloves. So today, I'm going to be turning this dish into a silver mirror using some chemicals. To do this, I just need to add some water to a beaker and dissolve some silver nitrate. After that, I can pour in some ammonia solution, which causes some of the silver to separate out for just a second. The last ingredient is sodium hydroxide drain cleaner, and I need to wait for it all to dissolve. The solution's ready, but I only need 100 mils, so I'm gonna pour it into another beaker. To get the reaction started, I have to add some glucose, and I can now pour it onto the dish. It's already darkening because small particles of silver are separating out, and I just need to leave it like this for a while. This is 15 minutes later, and now when I pour off all the water and flip it over, there's a nice mirror on the back. So for no reason, I've decided to make some Piranha solution, which is probably one of the angriest liquids that you can make in the lab. To do this, I just have to start with some concentrated sulfuric acid and then carefully add 30% hydrogen peroxide. It's important that I do this very carefully and to never add too much peroxide because it can actually become explosive. It also gets really hot, and this mixture is able to destroy most organic things. I always find it fun to add stuff like paper to it because it just instantly turns it into carbon and then it vaporizes it into CO2 gas. In the past, I've also done it with things like a fortune cookie, and it was able to completely destroy it in seconds. I also did it on a much larger scale, and I was able to dissolve an entire hot dog, which was kind of terrifying. This is ferrofluid. It's a liquid that's attracted to a magnet, and it likes to form a lot of small spikes. When I pull it away from the magnet, the spikes get bigger, but when I get too far from it, they completely disappear. Ferrofluid was first invented by NASA in 1963, and it's made by suspending super small particles of iron in a solvent. Here in Montreal, we've been finally getting some real summer weather, and I figured it was the perfect time to make some vodka popsicles. I don't drink, and I kind of hate the taste of alcohol, but I still thought it could be fun. The freezing point of 80 proof vodka is about -27 Celsius or -17 Fahrenheit, but my freezer can't go that low, so I have to use liquid nitrogen. It's taking longer than I thought it would, but it should eventually completely freeze. To get it out of the beaker, I just have to run it under some warm water. I now have a chunk of vodka on a stick, but it would be a horrible idea to lick it because it's way too cold. So instead, I'm just gonna try lighting it on fire. It's kind of sad though, because it's apparently too cold to do that too. This is arsenic. Arsenic's an element and it's classified as a metalloid, which means that it has properties that are between a metal and a non-metal. It can sometimes be found in its pure form like this, but it's usually found combined with something else, like sulfur and iron. Arsenic's very poisonous, and historically, it was pretty common to use it to kill people. People usually used arsenic trioxide though, because it was sold as a rat poison, and it was the easiest form to get a hold of. So today, I'm going to be making some test tube rockets. To do this, I first need a really strong oxidizer, and I'm using pure nitric acid. Now, all I need to do is add a fuel to it, and I'm using something called aniline. This mixture of aniline and nitric acid was used in some of the first rockets, but nowadays, there are more efficient combinations. It's also common to use combinations that don't light on fire on their own, like liquid hydrogen with liquid oxygen. This is Silica Aerogel, and it's one of the lightest solids. It's made from a very fine network of silica, and most of it is actually air. All of this air makes it a really good insulator, and I'm able to blast it with a torch like this for a while before it even starts to feel warm. The texture of it is kind of like styrofoam, but it's also very fragile, and it's really easy to accidentally break it. This is some Chromchloride that I made about a year ago, and it's one of my favorite chemicals. I'm not sure why, but I've always been a big fan of dark liquids that let off scary looking fumes. When there's a whole bunch of it, it almost looks black, but in small amounts, it almost looks the same as blood. I mean, if you ignore all the corrosive and carcinogenic vapor. Just like other angry liquids, it can be a bit of a pain to store, and it's often best to put it in something like a glass ampule. To do this, I made an ampule from a test tube, and once all the Chromchloride was in it, I sealed it with a blowtorch. This is iodine, which is an element, and it's chemically similar to chlorine and bromine. It has a strong tendency to let off fumes, and what I think is cool is that it can be used to develop fingerprints. To do this, I just have to put some of it into a smaller beaker, and then put that into a bigger beaker. I'm also going to put it on a warm hot plate to help make it fume a bit more. After that, I can put something in the chamber that I've touched, like a piece of paper. The iodine fumes start sticking to the oils in the fingerprint, and it slowly gets darker. To make the fingerprint permanent, it has to be sprayed with a starch solution, but I don't have a spray bottle. So I'm just going to try to wipe it with my finger, and that sucks.